Hello everyone, welcome to another section of Schneider Electric PLC training tutorials where you will learn Schneider PLC programming. Now let's see what we shall cover in this lesson. In this lesson we are going to learn how to insert contacts and coils to create a latching circuit, use created tags to link instructions to the inputs and outputs of the circuit, open the configuration of the CPU for our project, and download and test our project. Now this is our latching circuit. We already explained it in the previous tutorial, whose link I'm going to drop in the description box below. We have already explained its operation and we have already created a project, and that project was created in the previous tutorial. So we are going to open the existing project. This is our existing project and this is the project that we created in our previous tutorial. And in this tutorial we want to now transfer this logic into our software. So back to our software. First I'm going to drop a normally open contact, normally closed contact, pick this horizontal line, boolean connection, and then I will link them. Then I will pick a coil, I'll place that coil here. Next, I'm going to pick a normally open contact, drop it there. Then I'll pick this vertical line to create this parallel path. Then I'll hit the escape button to move away from the component selection mode. Okay, we have created our network. We will now assign addresses to these different instructions. To do that, you double click on the instruction, you hit this more option to browse. It's going to take you to the variable tables. Remember that we created these tags, okay, these variables, so we call them tags or variables. And here we are going to insert the S0 variable. Assign the S0 variable to this instruction, then we'll hit OK and OK. Then we'll assign the S1 instruction here. We'll select it, OK. I'll assign the run instruction here. Then I'll also assign the run instruction here. Remember, this is hold on contact. So if I've already used some variables in the program, I can easily access them from this drop down. You can see that they will appear in this drop down if I've already used them. So I will not need to browse to go to the variable table. So I can just select my run here and click OK. So we have successfully created our network, and now we have to start our testing. But before we do that, we have to analyze our project. So we'll go to the build menu, click on analyze project. So you can see we have 0 error, 0 warning. Then I'll build the project. We'll go to build all projects. So this is a project that is which we are currently working with, the latching project. Then I'll click yes. So it's going to say that you ask for complete rebuild of your project instead of generating only the modification. Do you want to continue? You click yes. And my project is currently built. You can see here that on the status bar that it is now built. After building our project, it is time to establish connection with our processor, which is our CPU. And there are two ways to connect our software to our CPU. We can connect our software to our CPU when we have a physical CPU, and we can connect our software to our CPU when we have a virtual CPU. That is when we just want to test our logic, and that is in a situation where we don't have a physical device. To do that, we are going to go to the PLC menu, and if we are working with a physical PLC, then we will go to the standard mode. If we are working with a virtual PLC, we are going to go to the simulation mode. So if I select the standard mode, I'm going to see this message asking me to confirm change of simulation standard mode. I'll take yes. So now I'm now going to there. I'm going now to the standard mode. And with the standard mode, it means that we have a physical PLC connected to our computer. And after setting it in the standard mode, you go to the PLC tab again. You have to set the address. And on the address line, you select the address sys and you will select the media USB and you test the connection. It says that there isn't a valid PLC address or PLC is busy or media is off. This is because I don't have a physical PLC connected on my computer. And we are going to test this logic by using just the simulation mode using the virtual PLC. So I will click OK and then I'm going to cancel. And now to use the virtual PLC, I'm going to go to the PLC tab. I will switch from standard mode to simulation mode. So ask me again if I want to confirm switch, then I will accept. I am now in the simulation mode. So I can now go to my PLC and click connect. My PLC is connecting. You can see here that it's showing that PLC is not built. I will go to the build option and I'll build my project. Now my PLC has been built. So if I go back to the PLC menu, you can now see this option is now changed to disconnecting, which my PLC is connected. I can now transfer my project to PLC. I'll click on that. Then I will select this option to run after transfer. My PLC is now going to the run mode. Then it's asking me to confirm run mode. Then I will click OK. So I'm now in the run mode, and you can clearly see that there is a logic flow from S0 to S1, and both switches have not been pressed. That is why you will see S1 is in red. S1 is in red, S0 in red, everything in red means that all the logic are false. Okay, they are not currently true. So this is normally closed. That is why you see the logic passing through, and this is normally open. That's why you see the logic is blocked because it has not been closed. The next, now we have to test the logic, and to test the logic we have to do that using the animation table. We will create an animation table for this. I will go to the animation table, then I will right click and then I will take new animation table. Okay, you can give your animation table a name here. I'll just allow the name table, and here this checkbox. If you check this box, it means you don't want the animation table to be saved when you close the project. So I will just allow everything default and then I will click OK. My animation table has been created, and this is my animation table. Now I have 0 variables on it or 0 tags on it. So to insert a tag, I will select my table. I will browse for the tag that I want to simulate. So I will select the S0 tag and hit OK. I can select all the tags that I want to animate. I will select S1 tag. Then I will select the run tag. So all of them are currently here. You can see that they all have their value 0 because nothing has been latched yet. Okay, I'm just going to rearrange my window and close some irrelevant windows. Okay, so that they lie side by side. Alright, so now let's start our simulation. And to start our simulation, first we have to be either in the modification mode or the force mode. With the modification mode, I cannot edit this variable. That is, I cannot modify it or I cannot simulate them because we cannot simulate a physical device. Remember, these are physical inputs and outputs, so we don't have the tendency to modify their values. Only if we had boolean here, that is not extended boolean, that we could have been able to modify their values, because that one is not tied to the conventional boolean, is not tied to a physical device. And now to modify these values, then I should go to the force option. You can clearly see that from the first option, I now have the tendency to modify the values. But with the modification option, I cannot access any of these force operation. And you should be careful when you're forcing a value. When you're forcing a value, you are overriding, like let me say input. If you are forcing an input value, you are overriding the logic that is coming from the field, that is coming from the physical input. The PLC is going to ignore that. And when you are forcing an output variable, then the PLC will just write to that output directly. Like for example, if I force this to 1, PLC will just write to it directly. Now we are going to press the S1 switch to force the logic to 1. So I will press it to 1. You see the logic becomes true, and since a push button, I will now release it back to 0. So I will release it using this icon. You can release it with this icon. Now our logic is still true in spite of the fact that our S1 has gone low. So to deactivate or to turn off this coil, I'm going to force the S0. So I will push it up. When I push it up, the logic becomes false, and if I release it, the logic will never go back to true, except, okay, the logic will never go back to true except I force this again back to 1. That's when the logic will go back to true. Okay, all right. Remember that you can always unforce it, okay, using this icon. So if I click it here, it's back in an unforced mode. I can push it down to go to false. Okay, I can push it down so that it goes to 0. Notice, for example, that if I latch this circuit, let's say I push it up, I make S1 becomes true, where the logic function, the logic is true at the output. You notice the F in front. The F in front means that it is a forced output, and I can release it by clicking the unforced. So it goes to 1. It's not forced anymore. I can push it back to 0. It is forced to 0. I release it. It goes back to 0. I can force this one to true so that it unlatch the circuit, and I release it. It goes to 1. It's not forced. I can force it down. I release it. It goes to 0. It's not forced. Okay. All right. So let's see what we have. Studied in this presentation. Okay. So we have placed the circuit. We have inserted the ladder logic. Okay. We have assigned addresses. We have completed the circuit. We have built and analyzed the project. We have simulated the project using the simulated mode. We didn't have a standard PLC, so we use the simulation mode. We have connected to the processor. We have downloaded the logic. We have used animation table to monitor and modify the values of our PLC tag addresses. Okay, we have seen the results of the simulation. We have forced the output to different values and see the different results. So congratulations, you have transformed a simple electrical circuit into a ladder instruction by performing the following tasks. Using the current path to create a logical flow for the instruction, inserting contacts and coils to create latching circuit, creating tags to link the instruction to the input and output of the circuit, uploading the configuration of the CPU to your project, downloading and testing your user project using the simulation or animation table. Okay, in the next lesson, we are going to see or understand what a ladder rung is. Okay, please, if you find this video helpful, hit the like button and share the video, as well as subscribe. And if there's anything you think has not been explained very well in this video, please do well to put it in the comment section, and I will take some time to review it. And if you think that there are some aspect in this video that needs improvement, please also share it with me in the comment section. And if you want to have amazing videos from our channel, then I will like you to subscribe to this channel. or head on to our site and get all the critical concepts that will enhance further training in this tutorial. Okay, thank you very much and see you in the next video.